So this is the question here, solve the inequality algebraically. So I'm going to do this algebraically, but also later I'm going to show you how it looks on a graph so you could relate what we've done to how the graph looks like and why we shaded where we shaded. Okay. So here, the first thing I could tell here is are my zeros or are my x-intercepts or my roots. So my zeros, which is the x-intercept on the x-axis, are x equals 1 and -3. And the -3 is a multiplicity of 2. So just remember that when we're going to graph later on. Once you find your zeros, there's not much to it after that except doing a number line. And so your number line is going to look like this. Throw your zeros on top of the number line, which is, if that's 0 here, then that's your 1. And it's going to be shaded because the inequality includes an equal sign and -3. So if that's the 0 and that's -3 right here, and it's shaded. Now you have 3 segments to this line, from -3 to -infinity, from -3 to +1, and also from 1 to +infinity. You got to test in all these line segments right here. Okay. So let's say when I'm testing, let's say I'm going to test -4. Okay. Now, one trick here you could do is, because you have x minus 1, x plus 3 squared is greater than or equal to 0, then know for sure whatever number you put in here, like even if it's a negative number and you end up with a negative inside, when you square it, it's going to be positive. So this is always going to be positive. So as a matter of fact, you don't even care to test in here anymore, because this is going to determine if the sign, that when you're testing the number, if the sign is going to be positive or negative, it's this part right here. So if we sub it in -4, all I need to do is just sub it into here. So I have -4 minus 1, which is -5. Is that greater than or equal to 0? Definitely not. So we don't shade there. Okay. Now let's take a number in this interval right here. So let's take the 0. If I put in 0 there, 0 minus 1 is -1. So -1 is not greater than or equal to 0. That's wrong. So therefore, we don't shade here either. Now let's take a number in here. Let's take 2, 3, 4, any number between 1 and infinity. So if we take 2 there, 2 minus 1, we're going to get +1. Is that greater than or equal to 0? Yes. Therefore, my solution is going to be here. That's where you're going to be shading. And therefore, the solution to this is going to be x is greater than or equal to 1. Let's look at how we could demonstrate this on the graph. Now, my zeros are -3, okay, and 1. Now, the thing here is that this equation here, the leading coefficient is positive. As I mentioned in earlier video, that you go to the 0 at the far right. If the leading coefficient is positive, then you go up. If the leading coefficient here is negative, then at the 0 at the far right, you go down. And now what you want to do, you want to go a little bit down, and then you got to come back to this 0 at -3, because that's the 0 that you have to go through. Now, because the -3 is a multiplicity of 2, which means you have a square on top, when you get here, you don't go through it. A square means you bounce right off, okay? And that's the guy in the graph you're going to get. Now, when they say this equation is greater than or equal to 0, basically they're asking you, when is the graph, or when is this curve happen to be above the x-axis? So from 1 on, this way, the graph is above the x-axis, and that's why we have x is greater than or equal to 1 for a solution. Also, the solution could be written as between 1 and infinity. Okay, so either this or this is acceptable. So x is greater than or equal to 1. That means from 1 on this way, or between 1 and infinity, which means the same thing. Okay. Wish you all the best with your exams. As always, thanks for watching. Till next time. Bye-bye.